Welcome to the Federal Aviation Administration's or FAA's virtual public workshop on departure procedure modifications for the Minneapolis-St. Paul International Airport. We're glad you can join us for this virtual meeting. My name is Eric Amond, and I'm the Regional Administrator for the FAA's Great Lakes region. I will be your moderator for today's meeting. This session will be recorded and will be available on the FAA's YouTube channel. So let's dive in. Our agenda today will start with a discussion on the flight procedure design process and our collaboration with local communities. This will be followed by an airport operational video and a video on performance-based navigation and area navigation, also known as Arnav. Then we will share a detailed presentation of the proposed departure procedures. After, our panel of experts will host a live Q&A session and we'll respond to your questions submitted on Zoom or on YouTube. The purpose of this meeting is to inform the public about the proposed modifications to the Standard Instrument Departures, also known as SIDs, at the Minneapolis-St. Paul International Airport. These modified SIDs will use a technology called Area Navigation, or RNAV. Using these modified SIDs requires the FAA to transition from ground-based navigational aids to satellite-based navigational aids. These modifications are designed to enhance safety and efficiency, reduce fuel consumption, and minimize flight delays while maintaining the departure dispersion over communities in the vicinity of the airport. Next, I will give you an overview on the process used to develop the flight procedures. The design of the flight procedures is regulated by federal law and address technical requirements such as minimum altitudes, turning radius, and emergency operations. Stringent reviews by various FAA organizations cover safety, environmental, and air traffic considerations. The process the FAA used to design and then review the proposed flight procedures for Minneapolis-St. Paul is the same process the FAA uses for similar projects nationwide. It is important for the FAA to work collaboratively with aviation stakeholders while developing new procedures. The stakeholders we have worked with on this project include the airlines, the Noise Oversight Committee, or NOC, and the Metropolitan Airports Commission, or MAC. Through the MAC, the FAA worked with the NOC. The NOC provided several initial recommendations on the design of the departure procedures. The following initial recommendations were included by the FAA in the proposed procedures. Number 1, use multiple departure headings to provide departure fanning. Number 2, use compatible corridors such as the Minnesota River and the Egan-Mendota corridor. And number 3, design procedures that concentrate some departures to the south for noise abatement purposes. I will now hand off the presentation to Christy Rigotti, our Environmental Protection Specialist, to talk about the environmental study process. Christy, over to you.
Hello, I'm Christy Rigotti, and I'm an Environmental Protection Specialist at the FAA. Per federal guidance in the National Environmental Policy Act, referred to as NEPA, the FAA is required to evaluate categories of potential environmental, social, and economic effects of a proposed federal action. According to NEPA, the proposed procedure changes are a proposed federal action. The environmental level of review for this action has not yet been determined. In order to determine the appropriate level of environmental review, we must first look at the potential environmental impacts and any possible extraordinary circumstances. Once these decisions have been made, the environmental process will continue following FAA and NEPA requirements.
In addition to answering your questions live today, public comments will be accepted until September 15th, 2024. You may send your written comments to the email address or physical mailing address shown on the screen, or you may simply scan the QR code shown on the screen with your mobile device. Next, we will share an airport operational video followed by a more detailed look at RNAV. Then our air traffic experts will present the proposed departure procedures. I'll join you again shortly for our moderated live Q&A session.
This video provides an overview of operations in and around the airspace at Minneapolis-St. Paul International Airport, or MSP. Minneapolis-St. Paul International Airport is an important connection to the world. It is consistently ranked in the top 30 airports in the country and is expected to grow in the coming years. The airport is an economic driver for the region, supporting nearly 87,000 jobs and nearly $16 billion in business revenue. In order to help it continue to thrive, it must continue to connect with markets worldwide. Technology is always updating, and the FAA is updating the technology that drives air traffic control. These updates enhance safety and improve efficiency of the airspace, benefits for the traveling public. Modernization can reduce delays while meeting current and projected demand. At MSP, a ground-based navigational aid, known as the VOR, will be decommissioned soon. VOR technology dates back to the 1950s. In its place, we will use satellite-based performance-based navigation, or PBN, to update standard instrument departure procedures. As part of this current modernization process at MSP, the FAA has been working closely with the Metropolitan Airports Commission, also known as the MAC. In addition, the FAA, through the MAC, has worked closely with the airport's Noise Roundtable, also known as the Noise Oversight Committee, or NOC. We're also working with the airlines, air traffic controllers, and other stakeholders to ensure community and user voices are heard. Our goal is to bring MSP up to the safety and efficiency standards seen at other airports nationwide, while considering community input in the process. So, how did we get here? When an airport is designed, the runways are laid out to align with the most common wind directions. This is because aircraft generally take off and land into the wind. In Minneapolis, winds can come from all directions. The runways at MSP reflect those varying wind conditions. As shown in this animation, MSP has 4 runways. Each runway end is treated separately, which means there are actually 8 surfaces. Runway identification is based on the magnetic compass heading the aircraft is facing as it lands or takes off. For example, runway 1230 has a compass heading of approximately 120 degrees in one direction and 300 degrees in the opposite direction. If you drop the 0 at the end of the compass heading, you will get 12 and 30. Parallel runways are further designated with L for left or R for right as you approach or depart the runway. This example shows aircraft in north flow. When winds are from the north, landing and departing on runway 30 left and 30 right. The other primary operational flows include south flow, when winds are from the south, and mixed A, which includes aircraft arriving and departing to the north, as well as departing to the southwest. Changes in weather mean there could be multiple operational flows in one day. Changes can also occur if the airport closes a runway for construction or snow removal. Air traffic controllers use 3-dimensional space to keep planes safely separated. Satellite-based procedures make that job safer and more efficient because the separation requirements can be incorporated into the procedure, enhancing safety and reducing pilot-controller readback errors. Creating and publishing new flight procedures is a multi-step process that involves multiple workgroup meetings with all stakeholders. We look at air traffic patterns in the area and make sure that any new procedures do not put that traffic at risk. The proposed satellite-based updates allow us to ensure aircraft from Minneapolis-St. Paul and surrounding Twin City airports are safely separated while maintaining a flow of air traffic into and out of the Twin Cities area. The MAC and the NOC have given the FAA valuable feedback during this process. We'll discuss that feedback later in this workshop. We hope this video gives you a basic understanding of how airports are designed, how the air traffic control system works in the Twin Cities airspace, and how planned technology upgrades will enhance safety and make the airport more efficient. For For more information, please visit the Minneapolis page on the FAA's Community Engagement website. This video provides an overview of changes taking place to modernize and transform the U.S. national airspace system. We will talk about satellite-based navigation and how this technology is improving the nation's airspace. Satellite-based technology enables the FAA to improve safety and system efficiency, reduce delays, and provide a better experience for travelers. One aspect of satellite-based navigation is called PBN, or Performance-Based Navigation. Traditionally, pilots have flown point-to-point using ground-based navigational aids. These ground-based systems are old, inefficient, and expensive to maintain. Congress has mandated the FAA use performance-based navigation at airports nationwide. PBN includes Area Navigation, or RNAV, otherwise known as Arnav, and Required Navigation Performance, or RNP. This video will focus on Arnav. Ground-based navigation using very high omnidirectional range navigation, known as VOR, has been in place for over 70 years. But much like technology in our everyday lives, it is being updated and replaced by a system that is more efficient. Performance-based navigation offers the most direct route between any 2 points, much like what you use when you take advantage of your car's GPS. Through the FAA Modernization and Reform Act of 2012, Congress directed the FAA to use PBN throughout the national airspace system. As a result, many of the old ground-based navigational aids are no longer needed, being decommissioned. As these procedures are developed, the FAA is taking care to recognize community needs. All satellite-based procedures, including RNAV and PBN, are developed specific to an individual airport, recognizing its unique environment, including land use and the residents who live nearby. Every effort is made to route aircraft over non-residential areas, including highways and open land, whenever it can be done safely. RNAV procedures can be used in the departure, en route, and arrival phases of flight. These procedures reduce delays and possible communication readback errors between pilots and controllers. When a plane leaves an airport, RNAV Standard Instrument Departure Procedures, or SIDS, follow a published route to provide a precise, predictable path for the climbing aircraft. Standard Terminal Arrival Procedures, or STARS, do the same for arriving aircraft. All procedures are published on flight charts. When aircraft are equipped with GPS or Flight Management Systems, or FMS, this guidance is programmed in, providing direction to the pilot at every step of the flight, reducing potential for distraction, and reducing potential pilot-controller readback errors. The FMS gives the pilot a predetermined departure path, or heading, altitude, and frequency for communications during each phase of flights. They can follow a heading or a vector that will disperse aircraft paths over a specific point. RNAV SIDS that use these type of headings are called vector RNAV SIDS. These procedures are developed with much study and care. The airport, airlines, FAA, and air traffic control join together to look at the airspace, the airport, and community needs, and other factors to determine what type of RNAV SIDS will be developed at a specific airport. PBN and RNAV, including SIDS, STARS, and other types of satellite-based navigation, improve safety by ensuring safe separation between aircraft. These procedures improve the safe, efficient movement of air traffic through the nation's airspace by providing more predictable flight paths, eliminating the potential for errors in pilot-controller readback. Please see our other YouTube videos for more information about how national airspace improvement is enhancing safety for all travelers.
Hello, my name is Robin Lohendorf, and I am a supervisory air traffic control specialist at Minneapolis Terminal Radar Approach Control, also known as the TRACON. I have been actively involved in air traffic for 23 years and here at Minneapolis since 2011. We will walk you through the flight procedure poster boards for the proposed departure procedures here at Minneapolis-St. Paul International Airport. Each of the following boards shows proposed departure procedures along with actual flight tracks. The flight tracks and procedures are all overlaid on a map of the surrounding area. Each flight procedure board is oriented with north facing up. The name of each flight procedure is shown by an arrow on the map containing a 5-letter name. For example, this board shows departures. These are called SIDs, or Standard Instrument Departures. The spelling of each departure procedure is limited to 5 letters. For example, the spelling of the NRTHN departure is pronounced northern. The diamonds on the board are locations of waypoints, which are fixed navigational points in space that are part of the published procedure. Just as with the spelling of procedures, waypoints are spelled with 5 letters. For example, the SLUSH waypoint would be pronounced slush. The proposed flight procedure arrows are colored purple for departures. These arrows show the general area of the proposed flight procedures. Surrounding the arrows are dispersed path areas in pink. These areas show the possible locations where aircraft may fly and also account for different routing to avoid hazardous weather, for our operational needs, for safety, or to disperse the departures. When aircraft fly in these areas, it is typically due to a pilot receiving a compass heading from air traffic control. We call them vectors. A vector is a compass heading assigned to an aircraft by an air traffic controller at Minneapolis Terminal Radar Approach Control, also known as the TRACON, or the airport tower. The bullet points on the right side of each of these boards provide additional details about the procedures. This board shows an overview of the existing aircraft activity in the greater Minneapolis area, including airports near Minneapolis. These airports include Anoka County, Crystal, Flying Cloud, and St. Paul downtown. As this board shows, the Minneapolis airspace is busy and is home to both commercial and general aviation operations. These general aviation operations may be small propeller airplanes that are training to become pilots, or airplanes flying for survey work. We call them photo flights. Business jet traveling between St. Paul and Flying Cloud and beyond. Law enforcement or medical transport aircraft, or even aircraft sightseeing over the Minneapolis and St. Paul downtown areas. The airports shown here each have their own airspace outlined in light blue, and aircraft flying to and from these airports communicate with air traffic controllers while in this airspace. In close proximity to these satellite airports is Minneapolis, with its airspace and flight tracks shown in dark blue. This series of 4 boards shows departures in north flow, which is aircraft departing to the north on runways 30 right and 30 left. North flow is used when winds come from the north. It is used more than the south flow here due to our typical wind patterns. These boards show the existing flight tracks in purple with the dispersion areas in pink. All aircraft are flying on a published departure procedure, or SID. These SIDs guide aircraft out of the Minneapolis area to join the en route airspace and ultimately head to their destination. This board provides a view of the broader metropolitan area. Following this board are more zoomed in boards providing additional details. When aircraft depart, they are assigned an initial heading by air traffic control. Aircraft fly this initial heading, which is typically in the general direction of their destination. A good example of aircraft being given initial headings to join a procedure is for aircraft flying to the northeast. Here, aircraft are given a heading that guides them to the Pike waypoint by following the northern SID. These aircraft continue on to destinations such as Boston, Syracuse, and Amsterdam. This board shows a more zoomed-in view of the existing flight tracks and proposed departure procedures. These are the same flight tracks and proposed procedures as the previous board, but zoomed in on the Minneapolis-St. Paul area. Air traffic normally assigns a departure procedure based on the most efficient route to the aircraft's destination. The proposed departure procedures are designed to replicate the current procedures as close as possible, including aircraft dispersed on initial headings. This board shows a close-in version of proposed north flow departure procedures and flight tracks. At this level of detail, you can see the multiple departure procedures labeled with arrows. Also detailed are the set of waypoints located approximately 7 miles from the airport. While these waypoints are part of the procedure, aircraft do not always fly to those waypoints before turning. Air traffic control will turn an aircraft on course before reaching these waypoints when it is safe to do so. This also allows our facility to be efficient, thereby reducing delays. The design of the proposed procedures will allow us to mimic how aircraft depart Minneapolis today, providing dispersion of flight tracks while maintaining the highest level of safety. This board is identical to the previous one, but now the flight tracks are colored by altitude. As you can see, by the time aircraft reach approximately 7 miles from the airport, they are generally at altitudes between 4,000 and 6,000 feet. The proposed flight procedures will ensure aircraft climb to specified minimum altitudes at each waypoint. These are also shown on the board. This ensures safety by keeping those departing aircraft above the airspace below, which is used by other airports.
Hi, my name is Matt D'Antonio, and I'm an air traffic control specialist and NACA training representative at the Minneapolis Terminal Radar Approach Control, or TRACON. I've been actively involved in air traffic control for over 16 years, and 12 of those years have been in Minneapolis. This next series of 4 boards shows departures in south flow, which aircraft is departing to the south on runway 12 right, runway 12 left, and runway 17. We will show a couple of zoomed out views followed by zoomed in views showing the detailed areas near Minneapolis. South flow is used when winds come from the south. It is used less than north flow due to our typical wind patterns. Just like north flow, aircraft are assigned a departure procedure by air traffic control to join a published route towards their destination. Today, when aircraft depart runway 17, they will turn to follow the Minnesota River, flying over less populated areas. When this procedure is followed, it ensures aircraft will climb to a safe altitude above bird activity over the river, as well as keep noise levels to a minimum over populated areas. These future procedures over the river will be more precise, keeping aircraft noise further away from populated areas while increasing climb rates. Part of the new proposed departure procedure designs in South Flow was intended to deconflict with arrivals and departures. This means that the proposed departure procedures will be separated from arrivals, reducing pilot-controller communications and enhancing safety, which is always our top priority. This board shows a more zoomed-in view of the existing flight tracks and proposed departure procedures. Aircraft are assigned an initial departure procedure based on the aircraft destination, operational need, and sequencing of aircraft to maintain required separation. Air traffic control normally assigns a departure procedure based on the most efficient route to the aircraft's destination. The proposed procedures were designed to give air traffic controllers the flexibility to manage air traffic for safety and efficiency, which inherently increases noise dispersion. This dispersion will allow noise levels to be more spread out to ensure minimal impact to populated areas. We also have incorporated the use of the Egan-Mendota Heights corridor, which maintains the existing noise abatement procedures. This board shows a close-in version of proposed south flow departure procedures and existing flight tracks. This board details the multiple departure procedures and waypoints located approximately 7 miles from the airport. While these waypoints are part of the procedure, as you can see, some aircraft are turned towards their destination before reaching these waypoints. This will increase the amount of dispersion of aircraft, which minimizes impact to surrounding communities regarding noise. The design of the proposed procedures will allow us to mimic how aircraft depart Minneapolis today, providing dispersion of flight tracks while maintaining the highest level of safety at all times. For aircraft flying to the southwest, the proposed procedures include following the Minnesota River for noise abatement procedures. Again, with our new proposed procedures, the aircraft will be flying a very specific route over the river while continuing to climb, which will then decrease the effect of noise over populated areas. This is the same as the previous board, but now the tracks are colored by altitude. As you can see, by the time aircraft reach approximately 7 miles from the airport, they are generally at altitudes at or above 4,000 feet. As of today, we do not have such climb restrictions. With our new proposed departure procedures, this will ensure aircraft are climbing faster, thereby decreasing the effect of noise over populated areas. These final 3 boards show what we call the mixed A operations, which is when aircraft depart to the north on runway 30 right, runway 30 left, and also depart on runway 17, while aircraft arrive on runway 30 right and runway 30 left. These boards show the existing flight tracks in purple, with the dispersion areas in pink for departures, and arriving flight tracks in orange, and dispersion areas in yellow. All aircraft are flying on a published departure procedure or an arrival procedure called a Standard Terminal Arrival Route, or STAR. These departure procedures and STARs guide aircraft in and out of the Minneapolis area to and from the en route airspace. This board shows the same flight tracks zoomed in to show how the arrival and departure tracks intersect, but use altitude separation of 1,000 feet or more to have positive separation at all times. Air traffic control assigns an aircraft departure procedure in mixed A, just as they do for north and south flow, dispersing aircraft and turning them towards their destinations when safe to do so. In this flow, currently aircraft arriving to Minneapolis are stepped down as they arrive, like walking down a set of stairs, while stopping on certain stairs or altitudes. The new proposed procedures will now allow these arrivals to descend on idle power without stepping down, similar to gliding in a continuous descent instead of leveling off and then descending. This change will allow aircraft to decrease fuel use as well as increase safety of flow of aircraft in and out of Minneapolis. We will continue to turn aircraft on course when it is safe to do so. This also allows our facility to be as efficient as possible, reducing delays. This board shows a zoomed-in view of the existing flight tracks and proposed departure procedures. This detailed view shows the areas located near the Minneapolis airport. Of note, aircraft will continue to use the Egan-Mendota Heights corridor to land. The design of the proposed departure procedures will allow us to mimic how aircraft depart Minneapolis today while providing dispersion of flight tracks while maintaining the highest level of safety. Our air traffic team has worked directly with the Metropolitan Airports Commission Noise Oversight Committee to ensure our new proposed departure procedures meet or exceed goals of keeping noise levels of the surrounding communities to a minimum. We have also worked with our airlines based at Minneapolis, including Delta, to ensure all procedures are safe and efficient. Our goal is to mimic the current procedures of today, while adding dispersion and altitude restrictions to increase climb rates close to the airport, which will decrease noise levels on the ground. We hope this presentation of the flight procedure boards was helpful. Up next, there will be a live question and answer session. Thank you.
Good evening and welcome. My name is Eric Almond. I'm the regional administrator for the FAA's Great Lakes region that spans the 8 states between the Dakotas and Ohio. Thank you for participating in our virtual public workshop. I will be the moderator for this discussion and I look forward to hearing your questions about our proposal. You may submit your questions at any time during tonight's session by entering them into the Q&A section in Zoom, or if you're watching us on YouTube, you may enter your questions into the YouTube chat. Please note the questions you submit during the Q&A session are not the same as submitting a formal written comment to the FAA. To clarify, there are two ways to interact with us. Number one, submit questions during tonight's session. And number two, submit a formal written comment separately. I'll talk exactly about how to submit a formal written comment later at the end of the workshop. Before we get started with the questions and answers, I'd like to cover a few procedural items. First, if you're having any technical issues connecting to the workshop, you may text our tech support number anytime during the workshop. That phone number is 949-478-0253. That's 949-478-0253. This Q&A session will last for at least 60 minutes, which will take us to around 8 p.m. Central. Yesterday, we had a great set of questions from the audience, and we are looking forward to hearing from all of you tonight. As I mentioned, we are live streaming on the FAA's YouTube channel. A recording of this workshop will be available on YouTube immediately after this broadcast. So, helping me out today, we've got a group of subject matter experts. Let me introduce our panelists. First, we have Sean Fortier, the FAA's MSP District Traffic Management Officer. Hi, Sean. We've got Robin Lohendorf, Operations Supervisor from MSP, Terminal Radar Approach Control. Hello, Robin. We've got Matthew D'Antonio, Air Traffic Controller from MSP Terminal Radar Approach Control. Good evening, Matt. We've got Christy Rigotti, Environmental Protection Specialist from the FAA. Welcome, Christy. We also have Michelle Ross, Manager Community Relations from the Metropolitan Airports Commission. Good evening, Michelle. And last but not least, we have Captain Clifton Sato, Technical Pilot from Delta Airlines. Thanks for joining us, Captain Sato. We're all very excited to discuss with you some of the work we are proposing at Minneapolis and then answer your questions. Everyone you see on this meeting today is committed to continue this meaningful and transparent dialogue with communities, and we're here to answer your questions about the proposed flight procedures. As I mentioned earlier, the FAA will be collecting comments on this proposal, so we encourage you to join in the conversation. Also, as I mentioned earlier, there are two ways to interact with us today. Submit a question during the live Q&A session and/or submitting a formal written comment. Formal written comments may be submitted until September 15th, 2024. How do you submit a formal written comment? That's a great question. Later in the presentation, we'll put some information on the screen that will tell you exactly how and where to submit your comments. Now, last night, we had a really robust set of questions, and we didn't get a chance to get through all of them. So we're going to start off tonight by picking up where we left off with a few of those questions. So let's get into it, and please get ready to submit your questions. Okay, here's our first question for our panelists. And let me read it as it was submitted, and then maybe we'll talk to our air traffic folks. Here it is. Is there a way to fan out the flight path on an approaching arrival instead of all planes using the exact same flight path? Using a fanned out approach would share the flight noise instead of the same areas receiving repeated noise. So maybe Cliff, maybe Captain Sato, maybe you could give us your thoughts on that, and maybe Matt from Air Traffic, give us your thoughts.
Hi, Eric. Thank you. That's a good question. And, departures and arrivals are different when it comes to how airplanes fly. For arrivals specifically, like on final approach as we're coming to the runway, aircraft have to be lined up a pretty good distance away from the runway on a straight in line to that runway for a number of reasons. But one is to make sure that we have safe alignment between aircraft as we're approaching to parallel runways. This is called simultaneous operations. So in Minneapolis, we have 30 left and 30 right, or 12 left and 12 right. We have to make sure those aircraft are flying straight into to those runways in parallel with each other so that there might not be any conflict between those two aircraft. But also having the aircraft lined up to the runway on that extended final is a level of safety so that we call it stable in the flying world. So that way there's a stability to the aircraft as we're landing. Landing an aircraft is, in terms of a challenge, much more challenging than taking off because it takes a lot more precision to put that aircraft down at the perfect place on the runway. So we have to make sure that we're lined up a long way from the runway on final.
Matt, your thoughts from an air traffic perspective?
Yeah, basically, Cliff was saying a lot of the things that we need to worry about as controllers and having them lined up safely on a specific flight path at all times. When we're doing instrument approaches, we do a lot of ILS approaches, instrument landing system approaches, and they can go out to almost about 30 miles from the airport on the runways that we have. And so using the parallel runways that we have at Minneapolis, that all depends on the wind. Again, some days we could be landing to the northwest because that's where the wind is. And the next day we could be landing to the southeast, and that could change also too. So depending on where you live, the arrivals won't always be there. It just depends on basically the wind direction.
Thanks, Matt. Thanks, Captain Sato. Captain Sato, I just want to pull on that a little bit further. Could you describe for the audience, because not everybody's, I'm imagining not everybody's an aviator. Could you explain what an ILS approach is in layman's terms?
An ILS
I should say. Sorry.
If anybody's seen Die Hard, the original from back in the day, ILS approach is a radio signal that comes from the ground, and it's a locked signal. So that signal points in one direction, and it has a lateral path which steers us left and right, and a vertical path which steers us down what essentially looks like, if you could imagine, like a slide in the sky. So that ILS has a very narrow beam, and it goes out to approximately 20 miles in terms of how we would operate with that ILS. So when we are vectored to the airport and we're flying ILS approaches, our aircraft are steered into that radio frequency or that radio beam, and the aircraft follows that radio beam down to the runway. It's a very reliable system in terms of precision. It's how we get onto the ground the majority of the time in most locations for the United States, but especially during bad weather, because as it stands today, the ILS is the instrument procedure that we use when the weather gets at its worst.
All right. I think that was an excellent plain language explanation, and I really appreciate it. For those of you out there who don't know what ILS is, Captain Sato's given us a quick overview. Thank you, Captain Sato. Okay, our next question, it says, I was in on the Zoom meeting yesterday, and I appreciated the new information on departures at MSP, but they didn't address the use of runway 35 at all. I'm wondering why. We're getting a disturbing amount of arrivals over our home in Apple Valley, and we're asking if that is where the arrivals will be moved to with these new departure plans. If not, what will be the plan for runway 35 after construction is finished? So let me go to Sean for his thoughts first, and then I'd like to get Michelle's thoughts from the MAC's perspective. So Sean?
Certainly, Eric. I believe that what this resident is speaking about is the increased amount of arrivals going to runway 35 during these past few months when we've had construction on the north parallel at MSP. And so this is a product directly related to that construction project. This construction project is estimated to end September 21st. at which we should see a return to normal flight paths on those arriving aircraft. Typically, as we discussed, aircraft land and depart into the wind. However, when one of those runways that we have is not available, we need to divert aircraft to the runways that are available. Similar to any type of construction period, there's a detour out there right now. So we would just ask for continued patience as we work through that. But I'll turn it over to Michelle for any additional response.
Well, Sean, I'll note, the MAC is conducting that necessary maintenance over the summer. And so I just want to acknowledge for that resident, we have noticed that increase in the arrivals to 3.5, as Sean said, due to the fact that we have 2 runways that are closed. And so air traffic does need to move those arrivals to the runways that are open. The work will be completed at the end of September. And as Sean said, we anticipate that the pre-construction flight patterns will return to the airport.
All right. I really appreciate that question from an audience member from yesterday, and I'm glad we had a chance to bring it into tonight's discussion, because it really illustrates the point that the traffic pattern right now, today, out of Minneapolis is not the same as it normally would be because of some construction impacts, right? Do I have that correct, Sean and Michelle?
Absolutely. That's absolutely correct.
All right. Well, and Michelle, you said the end of September is when we'll revert back to normal operations?
The end of September, the construction will be completed.
All right, perfect. Let's go to our next question. It says, when will the new departure procedures be implemented at Minneapolis-St. Paul International Airport? I'll take that one. The FAA is working to have these new satellite-based procedures in place by August of 2025, so a year from now. When the MSP very high frequency omnidirectional range, or VOR, that ground-based navigational aid will be decommissioned. And the current procedures are safe. Everything we're doing is safe, but they don't meet updated criteria for management of the national airspace system. So these new procedures with the new technology will help to enhance safety. And Sean, let me just ask, anything else you want to add to that?
No, Eric, I think you covered it well. Realistically, we'll be implementing these procedures as we move through our process. One of the things that we covered in depth and in detail last night was the collaborative process at which we had undertaken to develop these new procedures. I know it was covered somewhat earlier in the videos that were where we kind of discussed how we went about the process, but everything that we've been working towards with input from the Metropolitan Airports Commission and some suggestions from the Noise Oversight Committee will inform how those procedures will then be designed.
Perfect. Perfect. All right, we're going to change gears now, and I've got an environmental question. Christy, since you're our environmental expert, this one is for you. What environmental review is the FAA doing, and what is the status?
Sure. So currently we're still in the data collection and analysis phase of that environmental process. And that analysis will guide us to our next steps, which usually include consultation with agencies and tribes, and then a final decision on the appropriate level of environmental review that we're going to do based on the National Environmental Policy Act, or NEPA.
How do we, let's pull on this thread just a little bit. So how does the FAA leverage NEPA? And are there other environmental documents that the FAA references? I know we have an order, but let's talk about that for a minute.
Yeah, so FAA has kind of implemented its own way of following the NEPA, which is found in the 1050.1 order, our environmental impacts, policies, and procedures. And then that guides us through the steps of how we determine what level of environmental review we do. And so we have a few different categories that we follow. It could either be a categorical exclusion, an environmental assessment, or environmental impact statement. And those are really based on what our data collection and analysis shows. So there's a categorical exclusion, which that's when we look at, well, do we even have a category in our 1050.1 order that says this type of project could fit into that category? And if there is, then we move on to see if there's extraordinary circumstances involved. If there aren't, then usually we can continue on with a categorical exclusion environmental review. If there is potential for impact to any of those extraordinary circumstances, then we move on to an environmental assessment. Or if we expect that there could be significant impacts from the project, that's when we conduct an EIS or an environmental impact statement.
Wow, okay, great overview. Thank you for walking us through that. I think the bottom line though, today, as of right now, we have not completed our work yet. Is that right?
We're still in the process of that.
Okay. Okay. Here's the next question. And I got a side note here that I'm allowed to share this person's name with this. So I'm going to read the comment and the question, and then I'm going to share the person's name because I've been given the okay. So it says, your prior communications in part stated, quote, these upgraded RNAV procedures are designed to initially use multiple headings on departure, as is done today, to disperse traffic above the airport's surrounding communities. My question for our residents is what happens after the initial multiple headings on departure? In other words, will any community suffer more noise as a result of the subsequent determined headings after the initial multiple headings on departure? Please explain in detail and in layman's language. And this was submitted by Dan O'Leary, the mayor of Sunfish Lake. So let me go to Sean first. And Sean, it was a lengthy comment and then a question. I don't know. Do you need me? If you need me to read any of that back to you, I'm happy to do that. But otherwise, what are your thoughts?
Thanks, Eric. I think I've got the question down. As far as has been explained, yes, the air traffic control will continue to disperse the traffic on multiple paths, just as we do today. And that doesn't end right after the initial heading that we'll give for departure. We'll continue to disperse them and get them on course in the safest and most efficient way possible as they climb out. And, the secondary portion of that question, will other communities suffer or one suffer over the other? The answer to that is absolutely not. We intend to disperse the aircraft as they are dispersed today. There has been a lot of discussion regarding the desire for aircraft to be dispersed amongst the communities in the Minneapolis area as a result of initiatives that the Noise Oversight Committee has put forth. And so we understand that, we respect that, we've taken that interest, and we're putting it into action as we've developed these procedures.
Thanks, Sean. If I could ask our support folks to bring up one of our slides from earlier. I'd like to ask them to bring up slide number 6. Slide number 6. That's our north flow slide with some altitudes. And Matt, I'm going to put you on the hook in a minute. As soon as that image pops on the screen, I want to talk a little bit about what we're viewing here, because I think it fits in pretty well with the question that just came up. So what we're looking at here, well, actually, you know what? You don't need me to explain it. Matt, why don't you explain to the audience? I know it was in the video, but in case somebody tuned in late and there's a lot of information on this slide, if you could just describe what folks are seeing, talk about the key in the lower right, and talk about the pink shaded areas and how the flights are going to be dispersed.
Sure, yeah, thanks, Eric. Yeah, this is a very good map to show what our new procedures will be looking like. So as you can see, those darker black lines to the bottom portion of that map is the airports. It's runway 30 left and runway 30 right. And you can see all of those colors pointing to the northwest. Those colors represent that legend to the south, or the bottom of that picture. And as you can see, the red and the yellow means they're lower, and then the higher they get, turn blue and green and eventually get to pink. And so we'll take the northbound departure, for example. You could see where it says that north arrow VKNNG. We call that Viking. And aircraft that are departing to the north or to the east towards like Boston, they'll be headed that way. And then it's our job to get them turned on course. You can see that diamond just above the Viking arrow. It's like a tan pink diamond. And that's where they're headed towards. It says that WP3092. That's one of those satellite waypoints we're going to be using now. So as aircraft depart, they're going to get to a safe altitude. And as they get to a safe altitude, they're going to turn towards that waypoint. And depending upon the air temperature, depending on the type of airplane, depending on the pilot, they're going to be turning at different points. So that'll add to the dispersion of sound. So not every aircraft will be turning towards that direction in the same area. So as the airplane gets to that pink diamond above Viking, eventually, as controllers, we'll be able to turn them on course, reference any arrivals inbound, because just north of that, there's an arrival route. Airplanes are descending to 8,000 and our departures are climbing to 7,000 feet. If there's no arrivals, we'll be turning prior to that and getting them on course as soon as we can.
All right, thank you very much, Matt. And before we move away from this slide, I just want to point out a few other things for the audience. So you can see all these lines on the slide depicting flight tracks. These are actual flight tracks that we mapped out from an operational day in April. So pre-construction that we talked about earlier. These are actual flights that departed. And that pink shaded area depicts under the new procedures anywhere where the flights may be dispersed. So we received from the MAC and from the NOC the request to make sure that the flights were dispersed in the new procedures and the draft procedures, much like they are today. And as you can see from this graphic right here, that's exactly what the team has come up with. Now, this is an important point to remember that this whole session, if you're tuning in late or just joining us now, this entire session is being recorded. You can hear all of our comments, all the questions, all of the answers, see all of the videos. Everything will be recorded and available on YouTube right after we finish. Okay, let's move on to our next question. What would be the backup plan if satellite communication is interrupted for any reason? And many thanks for keeping the flying public safe. So, Robin, let me go to you first.
So we have contingency plans for safety. It's our number one priority. So we have a backup plan if anything were to happen. The FAA has a VOR, minimum operating network, which we call the VOR MON program. And it's a backup to revert to conventional navigation procedures. So this is the FAA's way of keeping some of the VORs around to serve this purpose. And then that way we still have some backup aids to use for any of our approaches that we need. And I don't know if Matt has anything to add to that.
Oh yeah, we basically probably revert to some of the departing ways off Minneapolis that we use right now with headings, and that would require some other coordination with other controllers to make sure to protect airspace. And without the Minneapolis VOR being there now, it would be kind of slowed down because we need to be watching these airplanes, make sure they climb correctly and get to certain altitudes better, because those climb restrictions won't be there anymore.
Great. Thank you very much. Thank you both for that that oversight of what happens if there's a satellite outage. All right. Next question. The maps are a little blurry. Will these be available after this call? The answer is absolutely yes. In fact, they're available now. You'll find on our website, and I'll give the website address a little bit later on in the presentation. Actually, it was in the initial video as well. The slides with all of the charts and the flight tracks that we've been showing, those are all available right now. And as I just mentioned a few minutes ago, the recording will also be available, and you can find that on YouTube after we finish tonight's session. Okay, here's our next question. Will greater use of the Minnesota River allow departures during south flow to produce a noticeable reduction for aircraft flying the Zumbro departure over the center of Eagan residential area? So will greater use of the Minnesota River allow departures during south flow produce a noticeable reduction for aircraft flying the Zumbro departure over the center of Eagan residential area? So let me go to Robin and then maybe Matt for their thoughts on that.
They also might turn to the southeast.
So I believe what they're looking for when we're departing to the south, stay off runway 17. We'll stay over the river as long as we can until they get to that appropriate altitude where we can turn safely on course. And then if they're coming off runway 12 right, we're staying on a heading until they get to a certain altitude until we can go on course.
Got it. Matt,
Yeah.
good. Matt, anything to add to that?
Oh, yeah, during our 12s, the departing 12 right, 12 left, and runway 17, we might still depart runway 17 to go towards Zumbro. And we will be mimicking what we're doing today in those situations to stay over the Eagan-Mendota Heights corridor to comply with the noise restrictions there.
All right, so same as it is today.
Yes, I'll be mimicking basically what we're doing today.
All right, good. All right, Matt, I'm going to keep you on the hot seat for a minute. How is the FAA able to add dispersion while moving to PBN, or performance-based navigation? I thought PBN always meant that the tracks condense.
That's a very good question. What the flying public needs to know is that these are not full RNAV departures. And so that means they're going to be only going to one point in the sky. And once they get to that point, or before they get to the point, we're going to turn them on course. At other larger airports like Denver or Phoenix or Atlanta, they have departure procedures where they will just basically hit every point in the sky and then eventually go on course. But for us, we thought that wouldn't be a good idea in our situation because we're surrounded by communities. And so by only having that one point that they go to, we can usually turn prior to that point or after that point, depending on traffic and complexity, to get them on course. And like I said earlier, they're all going to be turning to that point differently because every airplane will reach their safe altitude differently. And especially during colder days, they're going to climb quicker because the air is more dense. When it's hotter out, they're going to climb slower, so they're not going to climb as fast. So they're going to be turning probably a little bit later before they get to that point. So every day will be different. And also, depending on how ground control will set up these planes to depart, they're going to be departing probably in other ways to get to their destinations, where they're going to be going on a straight north heading or a 340 heading to the northwest, or basically straight west. So that's how they disperse the noise as well.
All right, so I want to pull on this just a little bit because I think this is a really, really important point that illustrates the great work of the working group. So if you have pure RNAV, what happens when the aircraft departs?
So pure RNAV, they'll depart, and when they get to the safe altitude, they'll go to their first point in the sky, and then basically get to another point in the sky, and then get to another point in the sky, and they're all turning over these same points all day, every day.
So it's the same. It's airplanes over the same exact spot all day long.
Yep, that is correct. That is correct. And so when we were developing this over a year ago now, we realized that would not be a good idea with how close our communities are, because we don't want to concentrate the noise in certain areas all day. So we wanted to make sure we'd mimic what we're doing today by dispersing that noise as soon as we can.
All right, good. I think that's a really important distinction for our folks out there that are tuning in this evening, that we're not doing that RNAV where it's pure RNAV, where every plane is going in the same exact spot. we're going to be dispersing flights just as we do today. Okay, Captain Sato, let me come to you. And this question asks, it says, how much involvement have the pilots and the pilots unions had in this planning change?
Thanks, Eric. I think I can answer this question while adding just a little bit more to the last question.
Please, absolutely.
So, the question asked was, doesn't PBN do this thing? And so I just want to clarify that PBN or RNAV isn't just one thing. It's not like, a singular hammer that does one job. So you can have RNAV procedures or performance-based navigation that gets you different results based on how we design these things. And, a lot of these things that we did today or that were done for this airspace design, we're using tools that would not have aircraft fly over the same point all the time. Even though they're still flying RNAV, they might be leading a waypoint, which means they'll be turning inside or outside of a certain point. And it's all based on the performance of the aircraft. So I just want to make sure we're clear that just because the word RNAV is used doesn't mean you'll be flying over the same point on the ground all the time.
Got it.
But to lead to that next question of how the pilots and the airlines were involved in this for things just like that. When we talk about how do our aircraft perform, and when we're looking at these procedures together with our air traffic controllers, with the procedure designers, and with the community, what is the impact of the procedures being created to safety, to training for the pilots, to efficiency of the airline? We look at this holistically as what is the total impact for us as an operation? Is it safe? Is it achievable? Is it within the realm of what we can do without large amounts of training for the pilot group? But surely how the aircraft flies is a big part of our involvement with this, in terms of what will the aircraft do if we ask it to do certain things is a large part of our stake.
Got it. Thanks for that insight. Thanks for the additional information on the previous question. I just want to remind all of you out there, if you're watching tonight and you've got questions or you want clarification on anything we've already said, please drop a comment or question into the Q&A section here in the webinar. Or if you're watching us on YouTube, drop something into the comments section there, and we're tracking, actually the chat section, and we're tracking both. Okay, so let's pivot back to, this looks like an environmental question. And Christy, it says, how do I find out what the impact of these changes is on my neighborhood?
Well, currently the environmental review is still ongoing. We're still collecting that data and analyzing it. But once we have that analysis complete, it'll be well documented in our environmental review document, and that will be posted onto the project website. And that'll be available for anybody to view once that's complete on there.
All right, so not complete yet, but once complete, it will be available publicly.
Yes.
Okay, I got it. Got it. Captain Cliff, let me come back to you. Here's a more specific question for aircraft performance. It says, how does faster climb rate reduce noise? Doesn't faster climb equal more power, equal louder engine producing more power?
Well, whenever we climb at Delta, we always climb at our max climb power. So the climb power setting we're using will always be the same. So when it comes to why is climbing faster or getting higher, reduce noise, it's a direct relationship to the distance away from the person listening to it, right? The higher off the ground we can get, the quieter we'll be. Stand in your backyard and watch a plane at 35,000 feet fly over and all you see is its contrail out the back and you can't really even hear it, versus an aircraft, much lower to the ground on approach. It's just that same direct relationship. The higher we can get away from the ground, the less noise that you'll hear. So we are always trying to achieve as high of a climb rate as we can for many reasons, but one is it's safer, and two, it's more fuel efficient.
Good. Excellent overview.
Eric,
Rob,
can I, not to
Yeah,
interrupt you, Eric, but maybe I could just jump in too, because, there have been some changes to our procedures with regard to what we use today versus what we will have in the new environment. And that was kind of discussed in the video, but specifically just to kind of rehash it. Currently, we use a 7-mile arc where aircraft have to be above that arc at 3,500 feet. And with the new procedures, those waypoints that are out there to ensure that aircraft are clear of the airspace of all of those satellite airports like Crystal, Anoka, Flying Clouds, St. Paul, those new fixes that are out there will ensure that aircraft are at 4,000 feet or above in many of those spots. Some of them will remain 3,500, but a lot of them are moved up to 4,000. And so that may be where that question was also originating, that they're going to be at a higher altitude. And I think realistically, and we kind of touched on it last night, and Captain Sato, please don't let me put words in your mouth, but I think as you described it, those waypoints are an agreement between air traffic control and the pilot that the aircraft will be above that point by that point in that geographical waypoint. But I'd let you expand if you wanted to.
you don't have to, but you're welcome to, Captain Sato.
To Sean's point, yes, when we put those altitudes on our maps, they're out there for a lot of reasons. We can, and in these airspace design meetings and why we do certain things, there's lots of reasons to do everything. But in this case, all those altitudes that were put around the Minneapolis airport, those are places in space where we're promising with air traffic control that we'll be above that altitude, mainly because we're trying to make sure that we have separation from all the other aircraft that would be underneath of us at that point. So, around the Minneapolis airport are many small airports with a lot of general aviation traffic and others. So it's a way for us to safely interact with each other as we're flying. If I can promise I'll be in a certain place at a certain time. So it's just an added level of safety.
If I could ask thanks, Captain Sato, and thank you, Sean. I want to keep going with this topic for just another minute, but if I could ask our support folks to bring up, it's slide number 11, which shows the arrivals and the departures together. And again, folks, the slide that we're going to put up on the screen in just a minute it was included in the video at the beginning of the session, and is also already on our website. So here you can see, again, these are actual flight tracks from a day in April before pre-construction, and the purple lines are the departures, and the arrivals are the ones in orange and the shaded area in yellow. So Sean, when we're looking at these waypoints out there, so let me just make sure I got this great summarized for the audience. You're saying that 7 miles out on the departure and under the new procedures, we're expecting the aircraft to be about 500 feet higher than it is today. Is that accurate?
In some places, yes,
Okay.
that's accurate.
And then the bottom line is what Captain Sato said earlier, that it's a matter of physics. You're further away from the ground, you're further away from people, so there should be less noise at that same point in space, right? Am I right, gentlemen?
That's correct.
That's right, Eric.
Okay. All right. Thanks to our support team for putting that up on quick notice. Appreciate it. All right. Let's move on to our next question. Very specific to a specific area right around the MSP airport. I'm going to kick this one over to Robin. Robin, what about the planes flying directly over my house in Bloomington? I can see the windows and delta on the bottom of the plane and the noise.
Unfortunately, Bloomington's rather close to the airport. So they're going to be, when we're on a northwest flow, the winds are out of the north. That's where the planes have to take off. So they're going to be lower to the ground when they're departing and lifting off. So Bloomington's going to get a pretty good view of the planes. And the same thing, and I know we talked about it earlier, how far out aircraft have to be established on final. So when we're in a southeast flow and they're lining up for landing on, 1-2 right or 1-2 left, everybody's going to be able to see those aircraft as they descend into the airport environment. They're going to be able to see what kind of aircraft it is, how many windows are on there, all that. And then even, if we're on a mixed flow and they're coming off runway 17, they're going to be turning over the river and climbing and getting on course as soon as we can. But it's just a matter of geography that Bloomington is that close to the airport, and they get a better view of the airplanes coming and going.
All right. Got it. Next question. Is there any new noise mitigation efforts for arrivals coming in from the Northwest, either to reduce noise and or frequency of arrivals? What mitigation for noise on arrivals for the noise that sounds like a downshifting groan? So Matt, you want to take that one?
Yeah, so right now we're concentrating airplanes to land runway 12 right because of our construction. In the future, mid-September, we're going to go back to landing both parallel runways, which will disperse the noise for runway 12 left and runway 12 right. Unfortunately, where the runways are situated, we used our historical winds back in the day to build those runways. So those are purposely put there because airplanes need the winds to take off and land. So they will be using those arrivals all the time if we're landing those runways due to the wind. And as for the downshifting groan, I'm sure Captain Sato can probably answer that question. I think it's probably because the pilots are putting out the flaps and slats, which helps them land safely. But I think Cliff can probably talk to that part.
I'm not sure I understand the downshifting groan, but maybe just from a basics of what we do to prepare to land. In one of the videos that began this this meeting, there was talk about optimized performance descent, it was called, or how do we get aircraft from altitude up in like the 30,000 feet all the way down to the runway with as little stops on the way, right? With as little to reduce the number of times that we have to level off the aircraft. So if you can imagine, your car going down the road, you're going downhill, you're not using the accelerator at all, right? It's just the momentum of the vehicle is taking you down the road, and your car is pretty quiet. And you can imagine going up a hill on a highway at 85 miles an hour and your car is pretty loud. So it's the same thing with an aircraft. Anytime the engines come up, there's going to be more noise. And so when we level off the aircraft, that takes significantly more energy than if we're just descending. So every time we level off, that's more noise. And then as Matt talked about, in our approach to landing, we're essentially trying to lose energy. So how do we do that? We have to put out all these types of drag devices like speed brakes and flaps, because we're trying to get the aircraft, we're trying to lose momentum from the aircraft, and that's like altitude and airspeed. So slowing down the aircraft, putting flaps and speed brakes out to lose that energy will naturally make us have to have higher thrust settings with the engine. If we can have an approach where we're constantly descending, those thrust settings will be lower. But yeah, generally it's essentially if you hear an increase in noise, like as the plane is flying to the runway, it's typically because the aircraft has leveled off in some portion of that approach.
All right, great. Thanks for that overview. For that person who submitted that comment, hopefully we addressed that particular element of your question. If not, feel free to send us a follow-up question and we'll see what we can do with it. Okay, moving on. I heard you mention the Eagan-Mendota Heights corridor several times. I live in Inver Grove Heights, and over the last 20 years, the flights have gotten more numerous and louder. Last night, we had planes overhead at 11 p.m., and I heard them again at 6 a.m. Will this change to Arnav reduce the noise we have here? Is Inver Grove Heights being considered for any noise abatement? And Sean and Michelle, I'd like the two of you to weigh in on this. And also, let's also look at this through the lens of the construction that might be impacting flights in this area. So Sean, you first, please.
Absolutely, Eric. So when we talk about the Eagan-Mendota Heights corridor, that is part of the voluntary noise abatement procedures that we have as a part of our runway use system. And that's a means of which we try to direct air traffic into either industrial areas or areas of what are referred to as compatible land use, where we might have a river valley. You can see that when we have some of our departure procedures that will go down the river as far as we can. So that was our reference to the Eagan-Mendota Heights corridor. We attempt to keep departure aircraft, especially in a south flow, over that portion in order to alleviate as much as feasible the noise impacts to residents. I can't speak to how this may or may not impact today Inver Grove Heights, but what I can say is that we don't expect any appreciable change as a result of the development of these new procedures, as we have tried to make them emulate as much as feasible the distribution and dispersion of the flights as we do today, while taking advantage of all of those compatible areas. But I'll turn it over to Michelle for any additional noise abatement concerns.
Absolutely. So our mitigation program does look at actual flight operations that occur every single year. So we do take into account the operations that are occurring this year with the construction that's ongoing. And so the eligibility for noise mitigation is assessed, as I said, on every single year on an annual basis using the actual data. And so if the homes in Inver Grove Heights met the criteria of the program, then they would be eligible for mitigation. So I would encourage this resident and anyone really interested in the MAX noise mitigation program to go to the website. It's metroairports.org/community. And there's a lot more information about the program and eligibility and all of the information about the program and how to contact us for more.
All right, Michelle, could you repeat that website just one more time, if you don't mind?
Absolutely. It's metroairports.org/community.
Got it. Thank you both. Matt, can we also see how the flight patterns will change before and after? In other words, faster dispersal equals tighter turns. So air traffic in the future will not be in places, will be in places where it was not before.
We're going to be mimicking basically what we're doing today, minus the construction the last, 2 months or so. So back in the spring, basically that's what you're going to be seeing. So when we developed our procedures, we thought the best option would be to mimic our procedures, what we're doing today, because it would disperse the noise as best as we can. I mean, right now we're concentrating a lot of planes on certain runways because we're limited to only a couple runways per day. And so depending on the wind, you will see more concentrations of airplanes in certain areas. But come mid-September, we'll be able to use other runways, which will really disperse the noise for departures and arrivals.
Gotcha. Thank you, Matt. Sean, Captain Sato, just offering it up in case you wanted to add anything to what Matt said. If you're good.
No, I have nothing to add to that, Eric.
No, I think Matt summed it up really well. I mean, I think it just reinforces, as we've said before, what we've tried to replicate as closely as possible what we're doing today. We don't anticipate any movement of noise today to a new community.
All right, thank you, Sean. And Sean, I was going to say, stay off mute because I'm going to give you the next question, sir.
All right.
So are there airports where this has been fully implemented? And what has been their experience? Did they achieve the benefits expected? So Sean, I want you to comment on this first. Captain Sato, from your flying experience, I'd like you to also comment on this if you don't mind. So are there airports where this has been fully implemented? What has been their experience? Did they achieve the benefits expected?
Yeah, thank you, Eric. There have been many of the airports across the national airspace system have implemented RNAV procedures, both for arrivals and departures. Minneapolis, in fact, implemented RNAV arrivals in 2015. We, at that time, were looking at RNAV departures. However, the mixed environment that was suggested at that time of using RNAV, pure RNAV on a rail, and vector RNAV, or RNAV with headings like we are designing now, it wasn't possible for us to mix those two at the time. That's why we took a pause and have reapproached the effort in this last year and a half. In that amount of time, though, since the advent of performance-based navigation, we talk a lot about the biggest 30 airports in the national airspace system. We call them the core 30 airports. Minneapolis is one of those. We are only a handful have not yet fully implemented. And so we are one of the last airports to implement. All of the airports which have implemented them have seen benefit. They have been able to tailor new procedures and harness the new technology, and they are all getting benefit from it.
Okay, thank you, Sean. Captain Sato?
Have other people implemented something like this? So I guess there's a couple ways to look at this. One is, have other airports incorporated RNAV? Yes. I mean, this is the future of how we're going to fly, flat out. This is the difference between me handing you your iPhone to get to a place you've never been before versus me handing you a compass. This is the next generation of how we navigate from one place to another. It is unarguably safer in every factor when it comes to how we get between 2 points in space. Now, as far as have other airports done things like this in terms of the tools we've used, like I said, there's multiple ways to do RNAV. The answer is also yes. A lot of the tools that we've used or looked at or incorporated were things that we saw in use in other places. When we talk about what will it look like when air traffic control vectors us off this SID, what will those flight paths, what will the behavior look like? There's lots of places around this country where we're expecting to have similar results. Essentially what we have in place in many of these departures is as a vector where we fly in a heading until we're clear of other aircraft and we get direct on course. So, where we go direct on course is highly variable based on the weather or based on arriving traffic or traffic from other airports around us. So by its very nature, it will create this dispersion because we're going to get vectors down course, down range to where we're going different places every day. So in both aspects, yes, this has been done before in other places with regards to the tools that we've used, and this has been done before in other places in terms of moving from VOR to RNAV.
So, Captain Sato, yesterday you made two really good points. I think it was in a couple of different questions, but I'm going to pivot back to that conversation from yesterday, and I want to ask you a little bit about it tonight, in case anybody who, ideally we have a lot of new people that are tuning in for the first time. So I'd like you to talk about the RNAV procedures in light of the workload that you have in the cockpit, or in the flight deck, I should say, prior to departure. and what that looks like. And also, you made a really good point yesterday about international airlines arriving here and using and taking off and using Arnav procedures. So could you talk about those two elements? I thought they were very compelling, and I think the audience will probably agree.
Yes. So, in terms of preparation for a flight, how do we get ready from entering the aircraft to taking off and leaving Minneapolis? We begin each flight about 30 minutes prior to departure. We'll receive what's called a clearance from air traffic control, and that clearance is kind of like the playbook. How do we get from our origin? In this case, it would be MSP to, let's say, Atlanta. That would have a departure. It would have an en route clearance, and it would have an arrival into my destination. Now, the way it stands today in Minneapolis, that departure is somewhat vague because our instructions for that departure are left till the last moment. Like, we know generally where we're going to go, but we don't have a specific instruction. And in today's world, that specific instruction is a heading and an altitude until we get onto the runway. And so why that's a challenge for us is because getting onto the runway is one of the most busy and high workload moments in the flight. It's a critical phase of flight. And, I don't want to anchor on negative things today, but, aircraft on runways is a big item today, safety item. We want to have high awareness of everything that's around us as we take that runway. So when we're preparing to take the runway, we're doing a final checklist that includes checking the configuration of the aircraft, making sure that the flaps are set, checking to make sure that we have the appropriate amount of fuel to make it from our to our destination, and that includes maybe some alternate considerations if the weather is deteriorating. We need to make sure that we're below our max weight, takeoff weight. We need to make sure that the winds are appropriate, that we don't have any tailwinds for takeoff, or if we do have tailwinds, that we factor that into our takeoff performance. All the while, we need to make sure that our flight attendants in the back are prepared to go and that our passengers are seated. And all that to say, if we could have instruction exactly of what we're going to do before all of those items are being completed, that makes it a much safer environment. So what we're moving to is an RNAV procedure that gives us those instructions 30 minutes ahead of time. The difference, now in the future, when we get this clearance for takeoff, instead of us having to manually go up into the aircraft and program in a specific heading told to us by an air traffic controller at that moment in time, that heading will already be in our flight computers. And all we're going to get from air traffic control now when we take off from the runway is clear for takeoff. So it reduces the communications. It makes it reduces the chance of error between air traffic control reading me a heading and what I actually hear and read back to him. And with regards to foreign carriers, the question yesterday was, what impact does this have for pilot training and especially our international partners that come into Minneapolis? Are they going to be prepared for this type of procedure? And the answer is absolutely. This is the way we operate almost entirely around the world now. So to not have RNAV procedures is actually out of the norm at this point. We want RNAV procedures because that normalizes what we do with the rest of the country and with the rest of the world. Part of that internationally being, this is radio communication back and forth between the pilot and the controller. So when we have pilots from around the world, Germany or Japan or whatever the case may be here in Minneapolis, some things can get lost in communication. Words sometimes don't translate well. If we can reduce the amount we're talking over the radio and make those communications data links or send them directly to the aircraft into our flight computers, that makes things much safer in terms of a certainty of what we're going to do when we take off from the runway.
Wow. All right. I'm really glad I asked excellent overview. And I want to thank the person out there that submitted the question about, whether or not we're using this today and its efficacy. Keep the questions coming, folks. We've got plenty more time, and we're here to do as much as we can and share as much of our insight with you as possible this evening. So, Robin, here's another question. What changes in air traffic are residents of Burnsville likely to notice after the proposed changes are made?
So two big things affect changes to air traffic, weather and the flight schedule, airline flight schedules. So for weather, it just depends on where the winds are coming from. We could have a week or two or more of southeast winds, so we're on a southeast flow. And then it could change for a day and you get a break and we're on a northwest flow. And so it kind of depends on what the weather is doing and what runway we're on. And then the other thing is the airline schedules. There'll be more traffic, more airplanes to move in and out of Minneapolis during, Christmas, the holidays, spring break, summer travel. Those are kind of some of the peak periods. So you're going to see more airplanes coming and going from Minneapolis during those times. As far as the way we get them in and out of Minneapolis, you're not going to see much change from that with the way we've designed the new Arnav procedures. We really tried to keep everything very similar to what we do today. It's just a more modern way of navigating in and out of Minneapolis.
Got it. Thank you very much. Okay, let's pivot to another question. And I just want to let the audience know that we're reading these questions. I'm reading these questions pretty much exactly as you've submitted them. So keep them coming. We're going to do our best to get through as many of them as we can tonight. I think this next one is probably best for Michelle. It's about noise abatement. Let me read it. Are there any additional plans to revisit nighttime noise abatement? I know there are weighted ratings that contribute to the consideration of subsidized housing upgrades. A house shaking frequently throughout the night after night, is a lot more impactful for most people than during the day.
Yes. So I first just want to acknowledge that, yes, flights that occur at night are more impactful to communities than the flights that occur during the day. And that's why the annual noise assessment that the MAC uses to determine eligibility for our noise abatement or noise mitigation that we provide, the sound insulation, we use the federally approved metric, and that metric does apply a 10 decibel penalty for every flight that occurs at night. So the hours are between 10 p.m. and 7 a.m. All of those flights basically get that 10 decibel penalty. And what that really means is that every single flight at night is like 10 flights during the day.
And you mentioned earlier where people can go. I'm just going to ask you again for the website if people want to know more about the MAX programs about noise abatement.
Yeah, our program website is metroairports.org/community. And there's more information about the insulation program and ways to contact us for more info.
Okay, excellent. Thank you. Next question. As a frequent traveler, I appreciate the safety aspect in these changes, but I believe most participants this evening are concerned about noise. What areas can expect an increase in noise, and who can expect a decrease? And this is based on normal flight patterns, not the recent patterns during construction. So let me go to Sean and then maybe Christy for their thoughts. So
Certainly, Eric.
Yep.
I think we've kind of restated this in different ways, but the reality is that, during our initial engagement and beginning the project and working with our partners, we identified early on that the communities had a desire to disperse traffic as it's dispersed today. And so I think that's probably the biggest driver in what determined how we developed the procedures. And in that sense, we don't expect communities to have increases or decreases. We expect that it will be much the same as what they experience, obviously, as you said, outside that construction period. Now, the only thing that may change things in the future would be additional traffic added to the airport. Obviously, we expect aviation to grow in the United States. The other thing that may influence would be additional airlines that enter into MSP coming from a different area of the country, or, you know, different cities are added to a flight plan for airlines that already operate here. But realistically, we don't expect this noise to shift to a new community that didn't have it before. We don't expect a community that had noise already to necessarily lose noise.
Got it. Thank you, Sean. Christy, how does the environmental process take all this into consideration?
Sure. So in that environmental review, we do look at several different resource areas. We have 14 that we consider, and noise is one of them. And in our noise review, we start out taking 60 random days throughout a year period, and that's how we build our baseline. We try to ensure that those are normal operating days at the airport. So we vet through those days to ensure that there weren't construction periods or maybe big weather events, so that they really do represent just normal traffic days. And then we factor in the fleet mix, and we talk to air traffic controllers to find out how they expect to move the traffic with these updated procedures. And then we compare that with that baseline information to see what, if any, change in noise is expected. That's going to be included in that noise report that will be included in the environmental documentation and posted on the project website.
All right, and just to clarify, because I know you covered it earlier, but just in case anybody's tuning in late or later in the midstream here, where are we in the process?
We're still in the analysis phase and data collection.
Got it.
So we don't have a final noise report yet, but we're working on it.
All right, this is a great segue into the next question, Christy, which I think probably is best for you as well. I'll read it to you. It says, the CADEX stated in your documents is from 2016. Are you saying you are going to do a new EIS?
I think that document might be referring to some of our historic data that's on the project website. I know that we have some documents towards the bottom of the web page from previous projects we've worked on. But at this time, we haven't finalized any of our environmental documentation, and we haven't determined the proper level of NEPA review that we're doing on this. But that's ongoing, and it will eventually be up on that website.
All right, got it. Thank you. Next question. I'm not sure I understand how there will be no additional noise, but this technology is needed to manage increased traffic / growth to MSP. Please clarify. Sean, you want to take a crack at that first?
Certainly.
Thanks.
So, you know, these procedures are needed for the decommissioning of that MSP VOR, which provides the current navigation for departing aircraft. As we talked about before, Congress mandated that the FAA modernize the national airspace system, and this is a part of that process. Arnav technology allows for reduced communication between the pilots and controllers, which we've talked about before. It's a better way of delivering information directly to our airline partners. And Arnav technology is a standard technology in aviation that allows for those safety benefits and the efficiency benefits. We can run aircraft more efficiently. So these routes allow for both pilots and controllers to know the route of flight right at the gate prior to their departure, and in order to get them to their destination.
Got it. Great overview. All right, let's move on to our next question. Can more waypoints be added for north flow departures? And will north departures climb faster like south? This is especially critical due to the anticipated significant increase in flights/airports use. So can more waypoints be added?
So Eric, the number of waypoints used was really determined by the number of departure procedures that air traffic needed. And so as we've discussed before, we tried to mimic the environment in which we're operating today. And in that case, it was the dispersion that we do today. The waypoints are out there to keep aircraft separated not only from other aircraft as they depart Minneapolis, but also to separate from the underlying airspace and aircraft that may be landing and departing at St. Paul, Flying Cloud, Anoka, and other airports out there. And so aircraft are going to climb in order to, reach those waypoints at the current rates of climb as they do today for those departure paths. As we said many times here, we expect it to be very, very similar to the performance that we see today.
All right, excellent. Thank you again, Sean. Okay, could I ask our support folks to bring up slide number 2? This is the slide that shows all of the airports in the vicinity. And while they're bringing that up, I'm going to read this next question, and Matt, maybe you can comment on it. Actually, maybe this isn't the best image for it, but I'm going to read you the question, Matt, and then you can talk through it because I think it's related to these airports. So it says, who decides where the pink diamonds are on the maps? So let's keep this image up for a second, folks, and then maybe pivot to maybe slide number 6, but keep this up for a minute and then we'll go to slide 6. Let me read the question. Who decides where the pink diamonds are on the maps? Why are the diamonds between Viking and Baitas closer together and Tots are further away?
Right, yeah, so Eric, thanks for the question. With this map that we're seeing, it just designates the satellite airports around us, which is Anoka to the north at A&E. MIC is the Chrysler Airport, to the southwest is Flying Cloud, to the east is STP St. Paul. And depending on the Roman configuration, we put those diamonds in specific locations to make sure we would be able to achieve a certain altitude above those airports to keep the safety of those towered airports and our departures as well. And if this support, people can go to slide 6. Slide 6 will show those diamonds that were talked about in the question. And the diamonds were determined by us air traffic controllers, again, to mimic what we're doing today. And those diamonds, as you can see above Viking, and then you see Bunyan to the northwest, and then Cabrew, and then Bites and Zumbro and Tots. Those are all there to make sure they're climbing above those certain airports. And also we have rules of separation. So in the radar room where I work, it's either 1,000 feet vertical or 3 miles. But we can also use from the tower, we can do 15 degrees of separation. Sometimes we could do 10 degrees if we're doing 2 RNAV departures, but we go with 15 degrees again to mimic what we're doing today. And so those are basically 15 degrees of divergence on all of those diamonds. And that's why they're the way they are. And whereas Zumbro and Tots, the map, this area doesn't show it too correctly, but those 3 lines to the southwest, you can see Zumbro, Tots, and Snows. They're pointing to where the departures are probably going to be going, but the fixes, Tots, is actually to the southeast of the airport. And that's going to be not one of the initial fixes that they go to. So those are just departure procedures that will be followed later on. That pink diamond just west of it will be named something different.
Got it. So, but the overall takeaway though is that these waypoints are guides for the air traffic controllers, and that's the agreement with the pilots to get to these certain points. But the controller's going to probably turn them prior to getting to these waypoints. It's not necessarily a fly over. And those of you that are controllers on the call here, help me out, make sure I don't go astray on the terminology, and Captain Sato as well. These aren't necessarily fly over points, but they're fly by waypoints, and the controller will turn them, and that gives us the dispersion that we have today and that we are expecting in the future. How'd I do?
Yeah, Eric, that's pretty much perfect. As you can see, the historical data that you're looking at right now, all those fancy lines around, that's basically what it's going to look like in the future, because in a full RNAV departure, they're all going to be basically one straight line. But you can see the dispersion from all the random lines in this map. So we built this to mimic the procedures we're doing today. So those diamonds you see are just a guide for the pilot to put into their cockpit. And then when they depart, they go towards that diamond, but it's up to us to get them on course as soon as possible. So depending on their climb rate and if there's any traffic in the area, we'll be turning them most likely prior to those diamonds.
Got it. Got it. Great. Thank you, Matt. Appreciate that insight. Folks, we're coming up on 8 o'clock. We're going to continue on. We've still got a bunch of questions to get to. If you've been thinking about a question and you haven't submitted it, please submit it in the Q&A section here on the webinar, or in the chat feature if you're watching us on YouTube. Sean, what is the comparison of the 10-year ago RNAV proposal versus the current plan?
So that's a very good question, Eric. So 10 years ago, when we first entered down the path of implementing RNAV at MSP, we had designed procedures that utilized the full capability of RNAV, and we described this a couple times, where they're a full RNAV procedure where they go point to point to point over the ground. And so, you know, there can be some benefits from the implementation of full RNAV. Every community is different. Every airport is different. What we looked at, based on the discussions that were held with the various communities and the Metropolitan Airports Commission, there was a desire to not implement a full RNAV procedure over certain communities. And so we looked at the possibility of implementing what we refer to as a mixed environment at that time. And there were safety risk management panels that were held, and air traffic at that time was not comfortable with moving forward with a procedure that was in a mixed environment. Looking at this project, we had taken guidance that had been provided by the team that worked on the previous project to start with stakeholder engagement early and ensure that we had the interests of all parties involved pre-decisionally. We sat down with our work group that consisted of pilots, members of the Metropolitan Airports Commission, obviously air traffic control, as well as PBN experts throughout the FAA, and our airspace and procedures experts within the FAA. And we discussed all the interests of all the parties, and the primary interest of the community representatives that were brought forth from the MAC, and Michelle, please correct me if I misspeak, were that we try to mimic the environment that exists today by dispersing the noise over communities and enhanced usage of our existing voluntary noise abatement procedures. And so that really was the foundational information that informed the design of these new procedures. So we went from full RNAV to now what we're utilizing with more dispersion. That's the difference.
So it's the idea is to get more efficient and enhance safety, but our approach is very much different than what we did 10 years ago. Is that
Absolutely.
okay?
Absolutely. You know, the FAA hands down, runs the safest and most efficient aerospace system in the world. We always start from a point of safety. Where does safety need to be met? And then from that point, we move on to the efficiency. And while examining both of those, we look at the individual community. And, you know, a huge point in the discussion was, you know, what does local air traffic need to be successful here while meeting those needs of the community? And, you know, it's a good point to mention as well at this time that, you know, your local air traffic control is a part of your community. And we all live here. We all experience the air traffic that lands and departs at MSP. And so we have a desire as, you know, good community members to listen to the community around us.
Good. Excellent summary. Let's change gears. Our next question is back to the environmental process. Christy, how will we know when the environmental review is complete? It sounds like you've made all the decisions, and the environmental review is just pro forma.
Well, the environmental review is part of the National Environmental Policy Act. And the FAA is required by our Environmental Order 1050.1 to determine whether there will be any impacts from the proposed procedures. That environmental decision document will be posted to the project website once it's finalized, and we anticipate that being final in around the mid to late January 2025 timeframe.
All right, very good. Thank you for that update. Next question. How will the new departure procedures affect arrival procedures and arrival flight paths? Matt, you want to take a crack at that one, please?
Sure, yeah. So for the most part, we will not be changing any of the arrival flight paths. The only change that we have is what our new departure off runway 17 to the southwest, where it turns over the river. That enables us to have a continued optimum profile descent for airplanes. And so right now, most airplanes are descending at idle and decreasing their fuel use, which saves the airlines money. But for right now, in a runway configuration of where we're landing to the northwest and departing runway 17, those airplanes get stopped. And it's up to me and my coworkers to get them down using communications to the pilots, and adds a little bit more complexity. But now this new procedure will add safety by having airplanes depart Minneapolis off runway 17, turn away from those arrivals, so the arrivals from the south can just descend via on their idle thrust power, and making everyone's job easier and less complex.
So that's a really good explanation. But Captain Sato, from an airline pilot perspective, what are your thoughts? How does this affect what you're doing in the flight deck?
For arrival and approach, as Matt just spoke about, you know, most of the stars will remain similar to today. But as far as,
I'm sorry, could you define stars for our audience?
oh yeah, those would be arrivals, like how we come to an airport from another airport.
Okay.
So, but the biggest impact to us is these, what he's calling, or what is referred to as, optimized performance descent. The goal is for us to just keep descending. You know, as we spoke about earlier, if we can keep descending, then we don't have to bring the engines up and use fuel and increase noise. You know, there's the obvious benefit, you know, in terms of the organization of less fuel burned is benefit to our bottom line, but also to the environment. You know, it matters to us at Delta. We have a goal at Delta Airlines of a net carbon neutral. And so the fuel we burn matters for us as a company and for the environment. So we want to ensure that we're doing as much as we can to reduce the fuel burned as an impact to both finance, but also the environment.
Okay, excellent. We got the air traffic control perspective, and we got the pilot perspective. The next question is, Sean, did you want to add something?
Yeah, Eric, if I could just add a point of clarity. When we talk about the change to that specific arrival, that pertains to the mixed A flow into Minneapolis. And so in that case, we would be landing and departing on runways 30 left and 30 right and departing as well on runway 17. And so I just want a point of clarity there. That's where we would be taking advantage of that opportunity. In other portions of South Flow, we already have that capability. So just in case people out there were wondering what the difference would be.
Appreciate the extra clarification. Folks, thanks for sticking with us. We're at the top of the hour. We're going to keep going. We've got a few more questions. The next question is actually a comment. It says, thanks for hosting this call. I appreciate your transparency and your willingness to host this session. Good information for the public, and I thought Matt and Cliff have done a great job of explaining things in plain language. So there you go, gentlemen. Nice compliment. I would also say, thank you to my panel, and thanks for some great questions from the audience. The goal for this project and these sessions right now was to be as transparent as we can with the community, right? That's been the goal from day one. We've collaborated with the industry. We've collaborated with the MAC. We've collaborated with the NOC. And we're really fortunate to work with the best and the brightest in this job and on this project. And I'm really grateful that we've had the chance to do these two sessions yesterday and today to talk to all of you out there to get your insights and your questions and provide some additional perspective and information. Okay, next question. Regarding noise mitigation efforts, what is the status of phasing out older, noisier aircraft at MSP? That's probably more of an industry question. Captain Say, I don't know if you have any perspective on what Delta's plans for fleet upgrades or things like that you'd want to share.
Well, yeah, I mean, we're excited to, talk about the fleet that we're building here at Delta Airlines. We're constantly buying new aircraft. All these new aircraft are designed with noise in mind. Delta's buying new A321neos. We're signed on to buy the 737 MAX. We're buying A330-900neos. All of these new generation aircraft have a much quieter noise profile. So, as we replace older aircraft with newer ones, we should overall through the system see a reduction in noise. And that doesn't just apply to Delta Airlines either. Every airline in this country is investing in new aircraft. So, will it change things completely? It'll be, I think, significant enough to see that there's a change over time of how loud these planes are. So we see a big benefit, and we're excited about it.
I appreciate the industry perspective. I'd also like to add that the FAA also is requiring aircraft to be quieter at our initial certification. They have to meet certain noise certification standards. And those standards are outlined in 14 code of the federal regulations, part number 36. You can look it up online if you'd like to. We also noticed, just anecdotally, that during COVID, when air travel was down, some airlines took the opportunity to retire louder, less efficient aircraft. So what's the bottom line? Industry is advancing. The FAA has regulations on noise for certification, and some other aircraft were previously retired. So the net benefit to all of you out there is that overall aircraft are getting quieter. Okay, our next question. Do the aircraft controllers have any responsibilities or oversight after aircraft takeoff? So maybe just a little bit of an overview of the process and the handoff. Let me go to Sean for that quick overview, and then maybe Matt, you can weigh in as well, and Robin. All three of you, because I'd like to hear the whole air traffic perspective. In fact, I'm going to change this. Sean, let's have you go last. Matt, let's have you go first.
So yeah, we definitely are involved with every departure that comes off Minneapolis and every arrival that comes into Minneapolis. Uh, in our situation in the radar room, we have standard separation of 1,000 feet vertically or 3 miles uh, from side to side. And so we use that separation at all times to make sure everyone is separated at all times to get in and out of where they need to go. Robin, I'll send it to you.
The planes are handed off from the tower to where you are, right?
Oh, yeah. So the tower will say to contact the departure control, which would be me. And then so I would work that plane away from the arrivals. And then I would bring that plane to the highest altitude that we own, which is 17,000 feet at Minneapolis. And then right before they get to 17,000 feet, it's my job to hand that airplane off to Minneapolis Center, who will now take that plane to cruise altitude to get to their destination.
All right, Robin, so what happens before the planes get to Matt?
So in the tower, they are getting their clearances either via that data link. They get taxied to the runway. They're given, the wind, that kind of thing, all the information they need before they get ready to take off. And then the tower is going to clear them for takeoff. They're going to depart down that runway, and then they'll say contact departure, and Matt will start talking to them.
right.
Yeah.
Is that it? All right, so the tower, sorry, I didn't want to jump in there too quickly. So the tower hands them off to the folks in the TRACON, right?
Correct.
Center.
Yep.
And then, Sean, what happens after that?
So from the center environment, or the en route environment, aircraft are sent towards their destination. They are continued to be separated. We have continuous oversight over the aircraft. We help them to avoid constraints in the system, such as thunderstorms or other weather phenomena. And then we direct the air traffic to the approach control again as they begin the descent. They'll go to the approach control, be given vectors to get to their final approach, and then be given a clearance for their approach and hand it off to the tower. The tower then gives them clearance to land. And so I think, the overall question here, looking at, do we have any responsibilities or oversight after the aircraft take off? The answer is absolutely. We have oversight of the aircraft during all phases of their flight, from the point at which they push back and enter into what we call a movement area, where we're controlling them on their taxi, all the way to taxiing up to just short of the gate, where we turn them over to ramp personnel to marshal the aircraft in. We're continuously monitoring those aircraft. We're continuously providing separation services to those aircraft. We're issuing safety alerts when necessary, and we're helping them to get on course in the most expeditious way to efficiently get them to their destination.
So the bottom line really is, from the time the aircraft is pushes back from the gate and is in the controlled area, air traffic controllers are handling them every step of the way.
That's correct.
Okay. Robin, let me come back to you. Here's the question. Technology is good. How do we use it to benefit all of the people in their backyards as this airport grows?
So these Arnav SIDs allow us to have a more accurate way of helping these aircraft navigate out of our airport. For example, off of runway 17, one of the proposed procedures, we are able to add some waypoints right over the river, so we can keep them over the river longer until they're high enough to get them to go on course. So it's a good way to modernize our airspace and keep up with the technology that's already around the world.
Okay. Let's go to our next question. Again, we're after 8 o'clock. We've got a few more questions lined up in the queue. Thanks so much for sticking with us, folks. Here it is. Why not use RNAV departures to follow compatible paths for longer distances? The Egan-Mendota Heights corridor, the Minnesota River Valley, and other major highway corridors, rather than fanning after a certain distance as you currently plan. In other words, use longer RNAV for some departure points. So, Matt, and then maybe Sean, if you'd like to comment, that would be great.
Oh, yeah, sure. Good question. Again, with these new proposed procedures, we tried to mimic exactly what we're doing today. And that is because our airspace is set up to have the flow of airplanes in and out of Minneapolis, as well as the flow of airplanes in our small satellite airports, such as Crystal, St. Paul, Flying Cloud, Anoka, and other airports such as Air Lake and Lake Elmo. We have a lot of flight training that happens around in this area. We have a lot of general aviation that come in and out of the area that don't use Minneapolis Airport. So we have to accommodate all users of our airspace. So our airspace is built where we need to protect certain spots where we can have airplanes that are departing Minneapolis because they're landing in St. Paul or landing South St. Paul. So it's important to make sure that we're accommodating everyone safely in our airspace at all times.
Sean?
Yeah, Eric, I'll just add that, we collaborated with industry to come up with these procedures. We also wanted to ensure when we collaborated with the Metropolitan Airports Commission that we were taking into account the concerns of communities out there. And so, being able to take all of those factors into account, that informed where those departure procedures were going to go. And, with regard to all of those things that Matt just talked about, there's a lot of constraints out there in the national airspace system. We have to find on-ramps into the en route environment that can get aircraft on course in a reasonable time to remain efficient. And I think we had talked last night a little bit about this, and Captain Sato had mentioned too that, oftentimes we would look for the most direct path to a destination if we absolutely could. And so there are portions of our airspace that would prohibit that. And additionally, the implementation of these procedures and the dispersion that we've put in there may somewhat inhibit that, but it is at the benefit of safety and the concerns of the communities.
Okay. Very good. Thank you, panel. We're at our last question for the evening. I'm going to read the question, and I'm going to attempt to answer it, but I'm going to need some help. So I would ask each of you to think about what you might want to add to my answer, and maybe frame it in terms of the collaboration that's gone on during this project and what has got us to this point so far. So here's the question. It says the FAA was going to put PBN in Minneapolis back in 2012/2013. The community wasn't happy, and you ended up not doing the procedures. Why are you coming back when we have told you we don't want changes? Why is this any different than 2012? Well, let me just say that you're correct. Whoever sent us that question, the process in 2012 was not how we're doing things today. And while we did follow the guidelines, we followed the guidelines that we have through NEPA back then, and we had to ensure that the procedures were safe. We quickly realized, and I know there was a lot of community feedback, that it was insufficient to ensure that everybody was happy, right? And so we had to take a different approach this time around. The community wasn't happy. The airport were not happy. So this time we had to make sure that all of these community groups, the Noise Oversight Committee, the MAC, everybody were part of the collaboration from the very beginning. The MAC and the NOC have been with us the whole way through this process. And we've had about 3 points in this project where we've provided windows for comments, including last night's session and tonight. The project has evolved with that community input, and it's come into very sharp focus. The change in our position, it's clear. These meetings, the breadth of the aviation community, talking to all of you, getting your feedback, getting your questions, answering those questions, and explaining in a very transparent way why we're making these changes, and spending several hours answering these live questions It's really the new way that the FAA engages with all of our stakeholders and with the community at large. We really want to make sure that we are putting the answers out there and answering all of your questions. So let me kick it over to the panel. Let me start with Michelle. Let's talk about the collaboration and the process as we wrap up tonight's session.
Yeah, so yeah, the MAC in this process, we did have the opportunity to provide input to the FAA. So we were able to share the unique aspects of our airport and our surrounding communities, share those perspectives with the FAA, and we also were able to connect the FAA with our MSP stakeholders, like the Noise Oversight Committee. And the Noise Oversight Committee did have that opportunity to provide some initial feedback to the FAA. And their feedback really focused on, dispersing aircraft, minimizing concentration of flight paths, and communicating the project impacts to the rest of the community. And that's really now, as you said, Eric, the rest of the community now has that opportunity to provide their feedback through this process. The comment period is open, and we encourage all of you watching and living around the airport to submit your comments to the FAA.
Okay, let's go to Christy next. Thank you, Michelle.
Sure. Well, what's different from a NEPA perspective now versus then in our collaboration is environmental folks are brought in early in the discussions, so we better understand the purpose and need of the project. We're able to meet with the MAC in this instance to understand the local concerns. We continue to work with our subject matter experts to analyze those potential impacts. And then in the past, we've had the document available upon request, but now we're being more proactive and posting it on the website. So everyone has access to it. They don't need to ask for it. It's right. It will be right there in January.
Got it. Thank you very much, Christy. Robin, over to you.
So as far as our collaboration goes, I mean, it was really a great amount of teamwork, a lot of listening involved with everybody and their wants and needs for this project. We, us air traffic controllers know how things kind of work at the airport here, but we don't really know what the pilots need to meet their climb restrictions, that kind of thing. So it was just a great learning process and experience to what everybody needed to make this work.
Thank you, Robin. Matt?
Yeah, so going back to the question of the PBN back in 2012, that was a full RNAV departure off runway 17. And these new proposed procedures are not full RNAV. All they do is go to a point roughly 7 miles away from the airport, and then they basically turn into what we're doing today. And even prior to that, as they're getting there with the dispersion. When we were developing this over a year ago now, we talked with MAC and the NOC directly. We were in all the same room, and we were bouncing ideas off each other how to make this the best. And the best way to would be to keep that noise dispersion as much as we can. And so this is not going to be what it was like in 2012 at all. This is going to be basically what we're doing today, just with new technology. And so we all work together to make this the best it could be. And I am looking forward to see how this is going to look in the future.
Thank you, Matt. Sean, over to you. Could you also talk about, in your answer, about, just as a reminder, like what the technology changes are in the retirement of the equipment?
Yeah, absolutely, Eric. Basically the current procedures that we have were not going to meet criteria for the future. The Minneapolis VOR is set to be decommissioned, and that really was the preemptive motivator to get into these procedures and address them again. We had to update the procedures because we had to move forward with the technology that is going to be available. And really, we had to come up with something that was going to work beyond that decommissioning of that 70-some-year-old equipment that's out there. So understanding that this was the problem that we all had to solve, we brought all the stakeholders together, examined the interests, looked for commonality amongst those interests, and then that's how we reached the consensus that is then driving what we're looking at today.
Got it. Thank you, Sean. Captain Sato, your thoughts?
I said this last night, and I'll say it again today. I feel proud and honored to be part of the team that made this. And like everyone has said before, the things that we have to do to combine all of our wants and needs into one is an incredible problem to solve. And it's really fun and amazing to see all these experts from different parts of the aviation world come together and solve this big problem. And in Minneapolis, to have the noise community be a part of it and integral to the entire process. So, I think we've gotten to a really good place, and I think we used every tool in the toolbox we possibly could to achieve the going in goals, which was to uh, make something tomorrow that looks like today using new technology.
That's great. Thank you, Captain Sato. I also want to add too, for our folks out there, that as I was talking about transparency and the way the FAA has approached this project, you can see all of our interactions, everything that we've documented. It's all available on our website. All you have to do is Google MSP Community Engagement, and that web page will come right up. It even has the links for today's sessions, and that's where all of our resources and materials are posted. So we're now at the end of our workshop. I want to thank you all for attending and spending some of your time with us this evening. We heard a lot of great questions, and I hope our answers were informative. If you want to review this workshop again or yesterday's workshop, please visit the FAA's YouTube channel. And we also want you to know that you may submit a formal comment on this proposal. Simply scan the QR code that's on your screen. It will take you to an email address associated with this proposal. Or if you'd prefer, there's a mailing address, and you can mail your comments to us. Please note that all comments must be received by September 15th, 2024. Once again, I want to thank our subject matter experts for providing their expertise tonight. Remember, this workshop is recorded. The recording, all of these slides, all of the videos, all of the materials, all of the addresses here on the screen, and the QR code will be available on YouTube right after we conclude. Thanks again for spending some time with us this evening, and we wish you a good night.